morning to all. As the host said, I'm coming to talk about project preparation and a case study of the use of line diagrams in maintenance works. Yeah, this is the outline of my presentation. Keywords definition, general outlook, tools, equipment required for the use of line diagram, key technical stuff involved, then the line diagram itself, and then the conclusion. Yeah. Before, project has various definitions, but I decided to use this. And it's saying that a project is defined as a sequence of tasks that must be completed over a period or fixed period and within certain costs in order to achieve an outcome. And that project has a start and an end. So it means the project starts and then it goes within a period and then ends at a point in time. Then we have site studies, which entails detailed site data collection of all parameters needed for the proposed project intervention. And this is actually the project level inventory. It's like you are diagnosing the road. So you need to take detailed information or parameters in order to achieve your objective. Then the line diagram is a representation of site data collected involving various work activities, and it is being represented in a simple diagram form to reflect the type of intervention required for the implementation of the proposed project. Now, let's have a general outlook of project preparation before we go into the line diagram preparation. So, project is a technical, financial, and social in nature. And the typical activities include identification of source of funding, needs assessment, community and stakeholder consultations, and then socioeconomic studies. This can be linked with the 5 project cycle phases, which is initiation, planning, execution, monitoring, and closure. They are all interrelated and they fall within these typical activities. Now, to do the project, we have the work breakdown structure, which is the WBS. And you need to do field surveys and investigations. And this entails traffic, soil and material investigations. You need to do safety and environmental impact study, selection of your alignment, and carry out designs, horizontal, vertical, cross-section, pavement, and then drainage design, among others. Preparation of drawings must be done. Technical specifications, both special and standard, too must be done. And then you cost the project, which is about the bill of quantities. Then from there, procurement process can, go on. Now, for the soil and material survey, you need to identify potential borrow pits for suitable gravel materials, sand pits, and chippings, that's quarries, for the project. You also need to collect material samples for basic laboratory testing to determine its suitability. That's gradation, CBR, Atterbeck limits, among so many others, for one to be able to get the right materials for the project. Then you select appropriate materials for the proposed project. For example, pavement structure. Then helps in preparation of special technical specifications for the project. And each project has its special technical specification. Then assessment of haulage distances of materials, which is very important because the quantity surveyors who are preparing the BOQ need to know the haulage distances and then be able to cost it very well. Then, like we said earlier, that project is economic, financial, and socioeconomic in nature. So here you need to do the socioeconomic studies. That is to identify economic needs of people along the project corridor. And then you do sensitization on HIV/AIDS. Road safety issues are very key. And then all these things must be incorporated into the VOQ. In fact, preparation, you need to have everybody on board. All stakeholders, everybody needed must be on board so that the project can be well prepared and take off well. Now, because this is a case study of the use of line diagram, we need to know the tools and equipment required for the use of line diagram. So we have measuring tape or measuring quill. We have hammer, cutlasses, pickers, shovel, and then survey instruments like handheld GPS, total station, etc., etc. The measuring tape will aid us to measure the length and width of existing structures, the road width, or using the measuring quill. And the hammer is to actually just determine the structural integrity of the concrete structures by hitting it. And when you hear some hollow sound, then it gives you the indication that the structure is weak. And of course, cutlasses and pickers, cutlass is to weed. If the place is bushy, you need to weed in order to see the existing drainage structure and measure it and see its suitability, whether it is still strong to do the job or not. And of course, pickers and shovel, we may have to dig, get some materials to go and test and so on. And the survey instruments are for the location of the drainage structures and other things. Now, because normally line diagrams are done in the regions, so the key technical staff are this: the maintenance manager, who is deemed to be the team leader. Then we have the road area manager, regional materials engineer, regional quantity surveyor, and then regional geodetic engineer. All these people are very, very relevant in the project preparation or the line diagram preparation. It shouldn't be done in isolation. One person shouldn't go to do line diagram and come. Everybody must be on board. So whilst the exercise is ongoing, everybody is looking at his area, taking notes. For example, the regional materials engineer is also taking notes of soft spots and suitable materials, and the engineer or the maintenance manager is also taking his inventory. So everybody is on board. The geodetic engineer is also there looking at his area. The quantity surveyor is also very, very important because sometimes they don't go to the field and they bring them the data and the line diagram. Whilst they are taking off, it appears to them that they are taking off in abstract, or they will not be able to see what they are taking off. So it is very important they are also part on the road so that they can also take their notes, and then when they come back and they are taking off, they know that they are not taking off in abstract. They've really seen what is on the ground. Now, having talked about project preparation, it's just an overview of project preparation. We now zoom into the line diagram itself. Like I said earlier on, the line diagram is being prepared in the region. And they go through all these things I've said about project preparation. But because of lack of time, the regions are compelled to use line diagrams, because to do a geometric design is laborious, time consuming, and by the maintenance nature of Ghana Highway Authority, the regions don't have that luxury of time. So they are compelled to use line diagrams, which is also very effective if done well. And like I said, it is a teamwork which involves technical staff with a team leader, which we saw in the previous slide. Then it entails detailed site studies. That's by mainly walking, observing and assessing, measuring and taking pictures. Very, very, very important. You have to walk. You have to walk, observe, take pictures, and assess everything into details. Some of the things you need to also check is the existing road condition. The road is sick, so you are going to diagnose it. So you need to know the existing road condition, like surface type, the defects, etc., etc. That will help you diagnose the road properly. Then also you should have in mind the road hierarchy. That is national road, interregional roads, and then regional roads, and select the appropriate width. The national roads have a width of 12.3, the interregional 11.3, and then the regional 10.3. It is very important to know the road class you are diagnosing. Then you should also know the geometry of the road width, length, the width, etc., etc. Now, whilst doing the line diagram, you need to pay attention to low-lying areas, soft spots, and take appropriate engineering decisions. Because I said it's a teamwork, so everybody is looking at his area and then having discussions as they go along. And then you need to mark out road sections that require realignment. Sometimes you may see that there is a sharp curve which needs to be realigned. So you have to, realign. Or you've seen that there is some rock outcrop around there, which will be expensive to, explode. So you may want to do realignment. And then drainage studies, which is very, very important because we all know that water is number one enemy of road. So as we do our designs or do maintenance interventions, we need to take drainage studies seriously so that at the end of the day, the road is not damaged by water. So you need to check and assess uh, the type of the existing type of the drainage structure, the type, the size, the length, the structure integrity. That is where the hammer comes in. You knock, you hear the hollow sound, then you give an indication that it's weak. And then its adequacy. And here too, I stated earlier on that projects, you need to involve all stakeholders. So here, it is necessary, or if necessary, you involve the inhabitants, the local inhabitants. That so when it rains, how does here look like? Does it flood? Then sometimes they'll tell you that you see this tree, when it rains, the tree is almost buried. And then here too, it's always flooding when it rains. You need to get that information too from the local inhabitants. And then also, you should also be able to go into the culvert and see the watermark. Sometimes the watermark will be very high. then that tells you that this culvert may not be adequate. Then also, you also need to see if there is a need to demolish or extend or replace, and then replace the existing drainage structure. And then also you have to look at for areas where you need to install new drainage structures. Either it's going to be a new drain or a trap drain or a pipe culvert or box culvert. You determine the size and etc. etc. That is for the new ones. We still continue on the line diagram, and what we are saying that it's a simple representation of site data involving various work activities. Very soon we shall see the work activities. And then it's being represented in a simple linear diagram form. And this guides the implementation of the proposed project. Yeah, these are the 6 main work sessions or activities that the line diagram has. Existing road parameters, clearing or demolition, earthworks, drainage works, road pavement, and then surfacing, then miscellaneous, that could be road safety and others, guardrails, road line marking, bollards, etc., etc. These are the 6 main work sections of the line diagram. Now, the 6 main work activities of the line diagram are now broken into details here. So existing road parameters, we are talking of road width, surface type, etc., etc. And then all work activities required, that is road side clearing, scarification of existing road, excavation, that's cut to widen or cut to formation in either in rock, fuse laterite, etc. Or fill to widen, or fill to formation, or fill to raise roads in low-lying areas. These are all part of the earthworks. Then we have the drainage works, where we have the covers and drains schedules. Then pavement works, sub-base and base course. Then surfacing works, primer seal and seal. And then road signs and markings. Then the miscellaneous, that I said earlier, that crash barriers, kilometer posts, safety works, etc., etc. Now, these are the list of the maintenance activities that we use the line diagram for. And the first one is upgrading or rehabilitation. Then we have resealing, then partial reconstruction and regraveling. All these activities, we can use line diagram to get a project out of it. Now, the first activity, which is upgrading or rehabilitation, these are the activities involved in order to achieve the upgrading or rehabilitation. So when you go onto the field to do your line diagram, you need to take these things into consideration. That is clearing or demolishing, earthworks, which is scarification, cut to widen, cut to formation, fill to widen, fill to raise roads, excavate ditches, and then drainage structures or drainage works. You culverts, concrete drains are also being involved in the upgrading works. Then, of course, pavement works, which is sub-base and base with other ancillary works. Then we have the surfacing works, that's the primer seal and seal. Because upgrading is bringing the road from a gravel surface to a bituminous surface. So definitely there will be primer seal and seal. Then of course you do your road line markings and signs. Then if there are other miscellaneous works like crash barriers, perimeter posts, we put it in there. Now we go to resealing. Under resealing, you do clearing, earthworks, pavement works, drainage works. Then you also do pothole patching if they are there. And then you do surfacing work, which is primer, seal, and then reseal. And then do your road sign and marking. Somebody will ask, resealing, but there is primer seal in there. Yes. Sometimes some sections might be so bad, the potholes might be interconnected, so there's no need to patch the potholes. So you rather clarify that section. And that is where the primer seal comes in. Then after that, you do your classical resealing, and then you do the row line marking. Then we have partial reconstruction, which is also having these activities, clearing earthworks, pavement works, drainage works, surfacing, of course, primer seal and seal, road signs and marking. As for partial reconstruction, you don't touch the alignment of the road. It's virtually the same alignment that you use. So at the end of the day, the road is still the same by way of alignment. That is why they say partial reconstruction. Then the last activity is regraveling, which entails clearing earthworks, pavement works up to sub-base only, and then drainage structures. Regraveling, we end at a sub-base. That's because the base material, the PI is lower than that of sub-base. So it's, if not sealed, it will disintegrate quickly. And the sub-base is more cohesive. That is why we leave or we terminate the regraveling on sub-base level. The line diagram is basically work activities versus road location. The work activities are in the vertical face of the line diagram, and then the road location is on the horizontal of the line diagram. Then you have dimension of each of the work activities. That could be quantity, which is volume or an area. Then you have the length, width, and height. And all this will aid the quantity surveyor to be able to quantify the volume of work. Yeah, now how to start the line diagram. So here it is assumed that you've gone to the field to do your project level inventory and you have it on your notebook. So you are now coming to represent it. So to start the line diagram, you choose a convenient scale. That is the distance in the horizontal face of the line diagram. And then you use arrow lines with arrows at both ends to depict the activities you are representing. And then you indicate start and end of the project. For example, the project starts at kilometer 5 and it ends at kilometer 15. Then also you start and end of each work activity has a start and end. Then we have the dimension of the work activity, which is obviously either length, width, or height. All these are represented in the line diagram. Then you need to indicate towns or villages along the road you are bringing back to life. Then, of course, we all have to be gathered by season when we are representing this and then doing the taking off. So having said that, this is a typical line diagram. We have the 6 main activities. That's the existing road width, demolish or clearing. We have the earthworks, which are broken into cuts to fill, cut to widen, etc., etc. Then we have the drainage structures, and then we have the pavement miscellaneous, and then under it is the legend. So this is a project upgrading of Wahabu Olembele to Tumu Road. So this is a typical line diagram. When you look at the first place, they say the existing road width, and you see they have represented with arrow, with lines with arrows at both ends, and they've written the width there that is 8.5. And like I said earlier, if this road is a national road, then you should know that at the end of the day, you should have a road that depicts the width of a national road. Then we have, let's say, under earthworks, we have excavation, excavation to widen road, and it starts from kilometer. This is 24. It starts from kilometer 27 thereabout to kilometer 28 point something, and it's saying that the height of the field to widen is 0.6, and then the width is 3 meters. We also have notes. The line diagram has notes column where you can also write notes there to guide whoever is taking off to get the BOQ, or at the time of implementation, this notes also guide the project supervisors. Now we have under the drainage structures, we have new drain, and then we have a trap drain and then culvert. Here they are saying that see attached schedule. Yeah, because it's very difficult at times, or most at times, to represent the new drainage structures right on the line diagram. That is why it is very important we have schedules for drainage structures, which we will be seeing soon. Now, one new thing that we'll be seeing is this earthworks. It's very difficult for the quantity surveyors to quantify it realistically. It's very difficult because it is just a representation of lines, and sometimes they find it difficult to, not difficult to calculate, they calculate, but most of the times it's not very accurate. So we are going to see something very soon about that. Now, this is the schedule of culverts on this project, the Wahabu Welembele Tumu Road project. So you will see that at change 24 plus 00, the type of culvert is 1.8 by 1.3 box culvert. Its existing length is 10.4. And how did they get the existing length? They measured. So it's very important we represent the existing features on the drainage schedule. So the remark is demolish and replace with new. So we have the new culvert columns. So this boss culvert will be replaced by or with two cell 1.2 diameter pipe culvert. And then the length is 14 meters. So the note, why are we demolishing it? Is because the existing culvert is weak. So it goes on like this. Some, for example, GNH 27 plus 550. The existing culvert is a pipe culvert. That's one cell 900 millimeter diameter. And the existing length is 10 meters. So we are coming to extend it. It means it's in good condition. So it needs to be extended. So extend 2 meters to the left and then 2 meters to the right, making a total extension of 4 meters. And then the remarks here is that extend. So it goes on like that. And if it's a new culvert to is there, install a new culvert. So this is the summary of the culvert schedule. So when you take, for example, single cell 900 millimeter pipe culvert, the total extension in meters will be 131 meters. That's the total extension of all the single cell 900 millimeter pipe culvert. And then for the total new culvert, they are 28. They are 28. And then the access covers are 20 and 8 meters length. So that will give you 160 meters. Then we have boss covers also here to be extended as well, as is shown in this typical drainage summary of covers. Then we have the concrete drains as well. Here is divided into two, U drains and then trap drains. So every detail is there. For example, the U drain starts from GNH 24 plus 1 and it ends at 24 plus 8. And the location should be both sides. And the type is 600 millimeter U drain. Here they have the town locations too. So this U drain is located in Van Boy town. And the next one is at Bande. Then same as the trap drains also. The cuts to widen, the field to widen, the quantity surveyors are not able to actually calculate it. So this is a new innovation that every line diagram must come with a vertical profile to formation. That way, all the F works are being captured here very accurately. So the quantity surveyors will just have to take it and then work with it. And with these two, it makes the implementation much easier because we have design to formation. As for side base is just thickness against the width, and then or it's in area. So there's no problem about that. So this is very important. Every line diagram must come with a vertical profile design to formation so that the volumes can be captured very well. In conclusion, line diagram, if done meticulously, it works very well. Then there is a need to conduct drainage design, that is hydraulic and hydrology. If the terrain is perceived to have severe drainage challenges, then here you have to do a proper drainage design. Then it's advisable to include vertical profile that's designed to formation, as I just said. And this will cater accurately for the earthworks, that's quantity and cost estimation. So thank you very much.